Hello, greetings from Alaska. I would have loved to have been there with you today in Duluth, but previous commitments in Alaska are keeping me up north. In the next few minutes, I'd like to introduce the unique opportunity for geological hydrogen in Alaska and briefly summarize the state of geological hydrogen research. I will start with the use case and briefly illustrate how the use case and the geological potential of Alaska may both align. And this means also that we have great opportunities for local use as well as export. That means that exploration development could be scaled and built initially for local use and expanded as transportation and storage is incrementally developed. This slide is a slightly modified version of the DOE slide that shows potential infrastructure needs and various use cases. Notice on the right the opportunities for mining, for local microgrid power, for communities or in military installations, rail belt, energy in our major area where we do have a gridded infrastructure, and then finally the potential to export hydrogen to places like Japan, all appear to be potentially viable pathways. This slide in particular highlights the importance of mineral deposits in Alaska. The presence of lode deposits in red on the slide on the left demonstrate the wide distribution. And on the right, specifically with critical minerals, I'm listing a demonstration of the broad extent of potential critical mineral accumulations that might be economic to mine. And again, in the next slide, we will show the geological links to that and geological hydrogen source rocks. Also in yellow, you can see sedimentary basins are in close proximity, and those sedimentary basins could provide reservoir traps and seals for conventional geologic hydrogen. This slide was developed by Steve Masterman, who is the previous state geologist and currently with the University of Alaska Fairbanks. And it shows the linkages in more geological detail between critical mineral deposits, ultramafic source rocks for geological hydrogen, and the geological features of the current subduction zone. If you look at it again, there are thousands of identified critical mineral deposits, and many of those are in association or close proximity to the ultramafic source rocks. Additionally, as you look at the two red lines there representing the subduction zone, the current subduction zone for the Pacific Plate, and you go from the left to the right, as it enters south central Alaska, you go from deep to shallow slab subduction. That creates a broad area for geological hydrogen to form within the areas of our current rail belt, energy structure, our communities, and the mining opportunities as well. So in that area, we could see a real opportunity for integration into grid-related hydrogen sources, and then also the potential to export those hydrogen resources to the Pacific Rim and places like Japan. On this last slide, I'd like to go quickly through some of the critical pathways needed to enable geological hydrogen, particularly in areas where additional research is badly needed, and also link to how the current activities link in some of these areas. So we have ongoing work, but is in the very preliminary stages. In terms of the regional assessment of Alaska, the USGS has an ongoing prospectivity mapping. It's well on its way to being completed, and it will be similar to that has been released for the lower 48 states. On regional assessment, geological assessment, the Alaska Industrial and Economic Development Authority, the University of Alaska Fairbanks, and Sandia National Labs are in discussions with key mining companies to do assessment in the Ambler Mining District, which is in the southern Brooks Range area. And Sandia Labs has done some geochemical sampling of eclogite from the Fairbanks area with encouraging results. And the University of Alaska Fairbanks has done some analysis of the linkages between hyperspectral data sets and airborne magnetic data with respect to understanding geological hydrogen potential. Site-specific assessment, the one case that I know of, and that's the Granite Creek Copper Company that has acquired licenses and is evaluating Volcan Mountain and Union Bay, both as critical mineral deposits, but also for their potential for geological hydrogen. And finally, there was an initial storage study completed by DOE Shasta in the Cook Inlet, which identified at least 7 potential storage reservoirs for geological hydrogen. Finally, many areas work has not started. We have not started to look for geological hydrogen seeps, important in Alaska in general, but also important to understand if there's an expression in areas that have permafrost. Licensing regimes and either the federal or state government have not been developed. Research and exploration drilling has not started. Economic feasibility studies and environmental assessments baseline studies needed for permitting and regulations have also not begun. So we have got a good start, but we've got a long ways to go. I want to thank you for the opportunity to speak today and wish you good luck for the rest of the conference.